Okay, calculus, let's finish 12.3 and start 12.4. The position vector for a projectile, neglecting air resistance, the path of a projectile launch from initial height h with initial speed v0 and angle of elevation theta is described by the vector function r of t equals v0 cosine theta ti plus h plus v0 sine theta t minus 1/2 gt squared j, where g is acceleration due to gravity. We derived this in the last video. So a baseball is hit 3 feet above ground level at 100 feet per second at an angle of 45 degrees with respect to the ground, as shown to the right. Find the maximum height reached by the baseball. Will it clear a 10-foot high fence located 300 feet from home plate? So let's substitute in. R of t equals, it's a 45-degree angle. The speed is 100, so this should be 100 times the cosine of 45. Ti plus initial height is 3 plus 100 sine of 45 t minus 1/2 our g in this case would be 32 t squared because we're in feet j. Now 100 cosine of 45, 100 times root 2 over 2, so that's 50 root 2 ti plus, this is going to be 3 plus 50 root 2 minus 16t squared j. Now, trying to find the maximum height, we need to find where the vertical value, the derivative, is 0, because the ball's going to go up or down, right? This is a constant based on time, so we really need to find where the y portion is 0. So let's take the derivative of the y portion. It should be 50 square root of 2 minus 32t. Set it equal to 0. Almost 2, so that means 32t equals 50 root 2. So it means t equals 25 root 2 over 16. I can take that and sub it back in for my height. So we've got y equals 3 plus 50 root 2 times 25 root 2 over 16 minus 16 times 25 root 2 over 16 squared, and we get 3. So 50 times 25 is 1250 times 2 over 16, so divided by 8. Minus, one of the 16s will cancel, but there's still going to be 1250 over 16. So we get y is 3 plus, this will also reduce to 625 over 8. So this is plus 625 8, which is 649 over 8, or a height of 81.125 feet. So it reaches a height of 81.125 feet. It says, will it clear a 10-foot high fence located 300 feet from home plate? So we really need to find how long is the t. So I need 300 feet from home plate means I can use this to find my t. So 1 is 50 square root 2t equal to 300. When t is divided by 56 over square root of 2. 6 over square root of 2, I can plug that back in for the height and see if the ball is still high enough to clear the fence. So again, plugging into y, we get 3 plus 50 root 2 times 6 over root 2 minus 16 times 6 over root 2 squared. It's 3 plus 300, because the root 2's will cancel. This is 16 times 36 over 2, which is just 8 times 36. It's 3 plus 300 minus 288 is 15 feet. So that means at that point, the ball is still 15 feet above the ground, which means it will clear the fence. And that is all for 12.3. Let's roll into the beginning of 12.4. It's tangent vectors and normal vectors. So the velocity vector points in the direction of motion. This observation leads to the next definition, which applies to any smooth curve, not just those for which parameters represent time. Definition of a unit tangent vector. If C is a smooth curve represented by R on an open interval, the unit tangent vector is defined as T of t, and it's R prime of t divided by the magnitude of R prime of t, where R prime of t is not 0. So we know a curve is smooth on an interval when R prime is continuous and non-zero. So smoothness is sufficient to guarantee a curve has a unit vector, because you know R prime of t is not going to be 0 if it's smooth. So it says find the unit tangent vector on the curve R of t equals ti plus t squared j at t equals 1. We've got R prime of t, which is the velocity vector. The derivative of this should be 1i plus 2tj. Just by taking the derivative of t and t squared. What is the length of this thing? The speed? It's the square root of 1 squared is 1, 2t squared is 4t squared. So it says if to find this thing, take 1 divided by that 1 plus 4t squared times my I plus 2tj. So we'll take my vector and divide it by the magnitude. And it wants it at 1. So this will become 1 squared is 1, so this becomes the square root of 5. I plus 2j, because again, t is 1. So this becomes 1 over the square root of 5i plus 2 over the square root of 5j, which does have a magnitude of 1. And we will do more in the next video.